right, welcome folks to today's webinar, Turn Amazon Redshift Serverless into a real-time data warehouse. I'd like to start by giving a quick overview of what to expect during today's webinar. So we will start by introducing Amazon Redshift Serverless. Then we'll move on to Absolver SQL Lake introduction and how it integrates with Amazon Redshift Serverless. This will be followed by a quick demo of Absolver's latest offering, SQL Lake, and we'll wrap it up with Q&A. Today with us, we have great speakers. Roy Hassan from Absolver, he's a head of product, and Manan Goel, who is a product go-to-market leader at AWS. And Manan, the floor is yours. Let's get started.
Thank you, Tatiana. Next slide, please. Hello, everyone. Welcome to today's webinar. So I'm going to kick off and talk about what we are doing with Redshift as a data warehousing service to make it easier, simpler, and faster for you to analyze all of your data. But before we talk about that, let me just start with the broader context of what we are hearing from customers like you, what's going on in the industry segment, market segment, and things like that. So first of all, this wouldn't come as a surprise to anyone who's on this webinar. What you're seeing is basically an explosion of data. I have a stat here from IDC, one of the leading industry analyst firm, where they talk about how more data is generated today in just 1 hour than what was generated in an entire year just a couple of years ago. So think about it, in the course of this webinar, as you're listening to this webinar, we would be generating more data. We collectively, as all of the humanity will be generating more data than what was generated in the entire year a couple of years ago. So, the point here is the volume, variety, velocity of data is increasing. You're seeing a data explosion. And this represents both a challenge as well as an opportunity. It's a challenge if you don't have the right data and analytics infrastructure to store, process, and analyze this data, because then you can run into issues like, you can have runaway costs, or you can have, sluggish performance from your systems. But imagine, if you had the right infrastructure, the right data warehousing, the right data lakes, the right data integration solution to manage this data, what a phenomenal opportunity it is. This explosion of data can really help you learn a lot more about your customers. So it can help you improve your customer experience. It can help you build better products and services. And it can really help you outsmart your competition and really excel in the market segment, if you will. So in that context, let's talk about, what does the right data warehousing or the right analytics infrastructure looks like, when it comes to managing this explosion of the data. So, I'm starting with data warehousing because that data warehouses are central to, the analytics and data management platform. So, with this, if you need to manage this, explosion of the data that you're seeing, the right infrastructure that you need to have, or the right data warehouse that you need to have, should be able to process data in any shape or form. Not just structured data that comes out of your transactional systems like, CRM systems or ERP systems, but you should also be able to store and process semi-structured and unstructured data like clickstream data or machine log data. The system should also be simple, where you do not have to worry about infrastructure, figuring out how much CPU, memory, compute you need. It should be as simple as a click button where you go in, launch the service, and the system behind the scenes takes care of, the management aspects of the data warehousing, whether it's, infrastructure provisioning or scaling or things like that. As we said, the volume, variety, or velocity of data is increasing exponentially. So the system should give you an ability to scale, not just scale up to meet, unpredictable demand, but then also scale down when there is no demand coming in. And with these capabilities, with the scalability, ease of use, the ability to process all the data, you should not be breaking the bank or paying more. You should only pay for what you are using. And the system should also give you top price performance, and help you analyze data in different styles and formats, whether it's real-time data, simple dashboarding and analytics, or predictive analytics. It should give you all of those capabilities at any scale. Imagine if all of this is available in the cloud. If you have these capabilities available in the cloud, you have a fully managed analytics infrastructure, which can help you like process any kind of data, scale as you need it, give you top price performance, and do interesting kind of analytics. That's the system that can really help you improve your operational efficiency, help you make well-informed business decisions, and accelerate innovation. So that's where Amazon Redshift, as AWS's flagship cloud data warehousing service, comes into play. Amazon Redshift gives you a fast, easy, and secure cloud data warehousing service where you can bring in data, structured or semi-structured data, terabytes to petabytes, analyze it with scale and performance, and really run complex SQL analytics on this data to find rich and powerful insights in your data. And within Redshift, we are building capabilities around three main themes or areas, if you will. The first is the ability to analyze all of your data. So this is where we are building capabilities with Redshift, whether it's federated query or data sharing, to go across data wherever it is. As we said, data is pervasive; it's stored in different places. So what we are doing on the Amazon Redshift side is giving you capabilities so you can go across data setting in operational databases, transactional databases, data lakes, data warehouses, and seamlessly run queries and analytics on top of that data so you can quickly find insights in your data. The second area where we are innovating in, and we'll talk a little bit more about it today, is giving you a system which is really easy, secure, and reliable. So the goal here is to give you a system which quickly helps you to go from data to insights in a matter of seconds or minutes without worrying about the infrastructure. So this is where I'll talk about some of the key innovations we have made. One of the key capabilities we have announced to make it really easy, secure, and reliable for you to analyze the data. And finally, price performance in a data warehousing environment, in an analytics environment, is key, because you do not want to pay extra for these capabilities. And that's where one of the key things that we have always done with Redshift is invested in Redshift's price performance. And we internally run benchmarks with standards like TPC-H, TPC-DS datasets, and we find that Redshift is up to 3 times faster than any of the solution that is available in the market today. So all in all, Redshift is a great platform for you to bring all of your data together, analyze it at its scale, and find really rich insights in this data. And certainly, customers have been, showing their confidence with the Redshift service, where tens of thousands of customers today across a variety of industry segments, across all regions in the world, use Redshift to analyze exabytes of data every day. So whether it's customers in gaming like Zynga or Dream11, financial services like Goldman Sachs or Coinbase, or healthcare pharmaceuticals, we have a variety of customers who are using Redshift on a daily basis to analyze their data, find the insights in their data, and drive business decisions. So, we talked about some of the key investment themes for Redshift. So one of the things which I wanted to drill down into today is the easy, secure, and reliable theme, and talk about, how we are launching new capabilities to make it really easy and simple to go from data to insights in a matter of seconds or minutes. So that's where I'm really excited to introduce Amazon Redshift Serverless, which was made generally available just a few months ago. And the idea with Redshift Serverless is to take away all the muck or complexity around launching and managing data warehouses. So you do not have to worry about the analytic infrastructure. You focus on building your applications, finding insights in your data, and underneath the cover, behind the scenes, we focus on infrastructure management. We take care of, the muck around infrastructure management, whether it's things like automatically scaling or patching the clusters or doing failover, backups and recovery, all of those kind of things, we take care of it. So that's what Amazon Redshift Serverless gives you. Now, in terms of capabilities, Redshift Serverless basically gives you benefits in four main areas. So first of all, it makes it really easy for you to get started with data warehousing. You can get started with data warehousing and analytics in a matter of seconds or minutes, if you will. With Redshift Serverless, there are no clusters or instances to manage. You do not have to decide, how much CPU, how much memory you want. You just simply go to the console, launch a Redshift environment, a Redshift data warehouse, uh, load some data into it, and at that point, you can start running your queries seamlessly. The other capability it gives you is consistent performance, consistently high performance, regardless of the data volumes. So we have capabilities like auto scaling built into Redshift, where, depending upon the workloads, the cluster resources will automatically scale up. And also, when resources are not needed, the the data warehouse resources will scale down to give you consistently fast performance. There are no changes or modifications required with Redshift Serverless. You can build your applications the way you are building, simply point it to, a serverless endpoint or a provision endpoint. And beyond that, you get all the good capabilities that Redshift offers in terms of, data lake queries, complex SQL analytics, materialized views, and machine learning, and all the interesting things. And finally, as we said, price and price performance is really important for you. So serverless even have capabilities built in, like auto pause and resume. So if there are no queries coming in, your cluster will go on a pause state, and you do not pay anything for compute at that point in time. So these are the main capabilities that Redshift Serverless provides to you. Again, a really interesting capability, with serverless now, Redshift gives you both multiple deployment options. You can have a provisioned server, if you want to self-manage the data warehouse, or you can go with, a serverless model where, AWS does a lot of management for you, and customers are using Redshift for a variety of use cases, so from self-service analytics, your classic business intelligence dashboarding, to more of a decentralized data analytic type use cases, whether it's data mesh, data grid, lakehouse architectures, to more predictive analytics like data science, machine learning, real-time analytics, data sharing, collaboration, or hybrid transactional analytics. There are a wide variety of use cases that customers use Redshift Serverless for. I also wanted to highlight some of the customer success stories in terms of how customers are using Redshift Serverless. So I have an example here from Roche, which is one of the largest pharmaceutical companies, specifically focused on cancer treatment. So, they deployed Redshift Serverless, and it gave them the ability to quickly get started with data warehousing, not worry about, scaling up or down, and managing the data warehouse infrastructure. So really accelerating the time to value for them. Another example I have is from Rail Delivery Group, which is the holding company for rail services in UK. So they manage, both the logistical railway side as well as the consumer railway sides in UK. They own the National Rail group within UK, and again, for them, they were looking for a platform which is self-service, easy to use, automatically scales up and down, and Redshift Serverless added tremendous value for them in terms of those capabilities. So finally, we are really excited about Redshift Serverless. We believe it can bring a lot of value to you in terms of getting started with data warehouses, in terms of managing data warehouses. We have a really great offer available for you to try out serverless, and we are offering $300 in credits to try serverless for new customers, as well as if you're deploying serverless, it comes in a pretty good price point. So really excited in terms of what serverless is, what it does, and how you can use serverless to build scalable, elastic, high performance analytic systems and get value out of it. With that, I'm going to turn it over to Roy to talk about the things that Upsolver is doing in terms of making your data pipeline simpler with Redshift serverless and other Redshift offerings.
All right, awesome. Thank you, Manan. This is really awesome. Switch to my slides. All right, cool. So again, my name is Roy Hassan. I'm the head of product at Upsolver. Been working with the Redshift team for a while. So really excited to see Redshift serverless coming out. I think many of you are really excited about it as well. When Redshift serverless came out, it was really about making it easy, making it simple for users to be able to deploy Redshift environment and run queries, right? So no longer do you have to manage infrastructure. It's all serverless, makes it easy. And it really aligns with the Upsolver messaging and what we want to give our customers as well, is that ease of use, the ability to do something with your data without having to spin up a lot of infrastructure, work with data engineers or infrastructure engineers to make it work. So in this talk, I'll talk about a few things, but in particular, I want to talk about the integration that we have with Redshift and a little bit of the kind of the mental model, how we think users should be thinking about or using Upsolver to be able to build data pipelines and to produce data sets in a quick and easy way. So before we get started, when we talk to a lot of our customers, and Manan kind of talked a little bit about this as well, companies want to be able to do more with their data. There's lots of projects and things that you want to do with the data to advance your business and to move forward. But the dependencies of the bottleneck of this data engineering teams to be able to build the infrastructure, build the jobs, transform the data, optimize it, and get that into the hands of analysts and product managers and marketing people is actually a big problem, right? That's kind of the growing delivery gap that you see here. It's hard to hire those teams or those people. And once you hire them, they're so valuable that they end up creating or working on things that are just not the most ideal for them, right? So they're working on DevOps stuff, like setting up monitoring, managing the infrastructure within the data pipelines, right? Creating the data pipelines, handling the schema. Like if something changes, how do I evolve it? How do I handle the, types that don't match, right? That cannot evolve automatically. Task orchestration, DAGs, creating these Airflow DAGs is actually not that simple. We see more and more users are kind of forced to create these DAGs to orchestrate their jobs, but it's not a simple thing, right? If you don't do it correctly, then your failure scenarios aren't accounted for correctly. You want to make sure that you do it right, and it's not a simple thing to do. So there's a lot of things that the data engineering team have to deal with. Redshift serverless is eliminating much of that from the serving layer to be able to say, like, don't worry about infrastructure, just click run and then start running your queries. Upsolver is coming from the data ingestion, modeling, transformation, and staging point of view, and is saying, if you want to bring data in, we want to make it easy for you, so you don't have to worry about all the infrastructure and all the underlying plumbing, if you may, to get the data into Redshift or into your target systems. And that's really a way for us to make it simple and quick to produce data sets, right? So going from months into days or even hours to produce data sets for users to consume, improve the data quality significantly. We're not duplicating effort. There's more awareness of what you're producing, making it sustainable, right? Like if you start building Airflow DAGs, like you're going to have lots and lots of DAGs. As more people use them, they get more complicated. It becomes a big technical debt, and that's only one part of it. And then reduce the cost, right? The more systems you have to help you manage your environment, the more things you build on your own, the harder it is to manage, the more costly it is longer term. And at the end of the day, like our data engineers, we love our data engineers. We don't want to burn them out. We don't want to, strap them with a bunch of grunt work that they just have to do. Those are the kind of things that our tools and our capabilities and our features can deliver on. So before we kind of get into what Upsolver is, I wanted to take the idea of a data pipeline or producing data sets and separate it into data producers and data consumers. We see this often with many of our customers, especially in like a data mesh type of world where you have people that are producing data. Those are people typically that are running the microservices, your applications, your logs, whatever that may be. They're the producers of the data, right? They want to be able to take their data sets and just quickly expose it to the business. Maybe they don't know how people are going to use it, but they know what the data looks like. They know what the schema is. They know a bit of the contract, right? Like what to expect of the data, and they want to expose it quickly. They want to define that contract, that schema, and say, like, this is what the column names are going to be, what the types are going to be. Maybe they want to model it a little bit. Maybe they want to say, look, we understand the business and our naming conventions are kind of weird, so we're going to rename them. We're going to change that a little bit to make it easier for the end consumers to really understand. And that comes along with documentation, updating the catalog and things like that. But once they're producing that data, they also need to have a little bit of an ownership on this. The schema changes, they're responsible. If somehow the source system stopped producing event or introduce some corruption into the data, they need to be aware of it and they need to be responsible for fixing it. On the flip side of that, you have the data consumers. Those are typically the business users, analysts, data scientists, product managers, et cetera, et cetera. They're really about finding data sets as quickly as possible, understanding what the data set is all about, and is through profiling, through running some queries, through reading some documentation in a catalog. And then they want to be able to take that data and transform it and mold it in ways that make sense for their use case, right? So if it's clickstream event data, a product manager is interested in, how well the website is performing and the buttons in the right place. They have a certain view of the data, but a marketer may look at it differently. But we don't have to create two different data sets. It's the same source data. We just create two different views of that data. And then ultimately they want to put it into a tool that makes sense for them. Whether I put it into Redshift or I leave it in a data lake, or I bring it into Amazon SageMaker for some, for some machine learning. If I want to do personalization or whatever that may be, I want to be able to do it. And then all of this needs to be done in a consistent, simple to use language, something like SQL. We don't want to ask the user and say, well, for this task, you got to use SQL, but for this one, you got to use Python. And in this case, it's a little bit weird. So you're going to have to do a mix of SQL and some Python UDF and maybe add some Java. Like, no, we can't ask our consumers to do that. We got to be consistent. We got to make it easy for them. So how do we do that with Absolver? So the way we're thinking about it is Absolver is a stream processing engine that allows you to define your data transformations using SQL. And behind the scenes, Absolver automates and simplifies all of the heavy lifting of delivering a reliable, accurate, and consistent data product to the end consumer. So bringing data in from a number of different sources, whether it's streaming, object stores, databases, SaaS systems, we treat all of that as a stream of events coming in. So the user doesn't need to know, oh, it's a file, oh, it's a Kafka stream, oh, it's a database table. To them, it doesn't matter, right? It's just one thing, there's consistent experience. Once the data is coming into Absolver, there's kind of these three layers. The first layer up top is the user interface. How do we make it easy for users to be able to on-ramp quickly into the platform and start building and start producing value for the business? And we do that by exposing all of our capabilities through SQL. So you can create a connection into Kinesis. You can create a table that reads from Kinesis and then, a job that reads from Kinesis and writes into a table. You can then take that table, transform it, and then write the output into Redshift or into a data lake or back into Kinesis, right? So all of that interaction is done through a SQL interface. Now, once you've done that, you read from one source, you transform, you wrote to another table, you read from another table, you join, you aggregated. All of that, you already told us, what are you doing with the data? How you want the data to flow through the system. So we take that information and we basically compile it down into an internal DAG representation, right? An internal pipeline representation that it instructs the engine under the covers to stitch all these things together. So now if there's multiple steps in your job, but one step in the middle fails, or maybe the first step that ingests data into the pipeline fails, the rest of the jobs, the rest of the steps are aware. So they're aware of the data that is coming in. If there's any issues with the data, if a row gets dropped, all the rest of the jobs are aware of it. If the source system, Kinesis, for example, for example, just stop producing events for some reason, right? There's no point to continue processing more data upstream because you could be producing bad data or incorrect data. So Absolver is smart enough to say, hey, no events are coming in. I'm going to stop. Like, I'm going to stop these other jobs from doing things because there's nothing for them to do. So that's a really important aspect where in today's world, if you're using something like Airflow, the end user have to think about all of that logic and implement that logic into a DAG. Absolver just learns it automatically from what you're doing, from what the SQL is telling us, and we build that automatically and we manage it for you. So all that orchestration is done for you. We transform the data, we write it out, we optimize it, we do compaction of the data in S3, we do optimizations of partitioning and things like that. So all that heavy lifting is managed for you. And then under the covers, very similar to what Redshift Serverless is doing, we manage all the infrastructure for you, spin up servers, spin down servers, making sure you have enough memory. If there's not enough memory, we spin up more servers. We use S3 as a staging place for all the data. So a way for us to synchronize the state between the machines, between all the different clusters in the environment. Everything is cached, so it's low latency, but we use S3 as a way to allow us to scale. So the more nodes we add, everything's reading from S3, it's much faster, right? And we ability to scale very, very quickly. And then once you're done with that, the output gets sent into your data lake, your data warehouse, into your databases, back into a stream system, whatever that may be. So again, that's kind of what Absolver is, and this is what the SQL Lake product is all about. If you have any questions, drop them in the chat or in the Q&A box, and we'll answer them towards the end. Okay, so there's a couple concepts I wanted to introduce here with regards to how at Absolver we think about this concept of producer-consumer. That's a big component of data mesh. And we've actually implemented this in an opinionated way in Absolver to actually make it easy for companies to think about it and to distribute the responsibilities between the teams. So the way that we think about it is we have two types of jobs in Absolver. The first one is we call it a copy from. And think of that as a job that reads from a source and stages the data into the data lake. So by default, we write all the data into the data lake. So you have a staging place. What that does is it gives you the ability to quickly discover what data sets available. So if it's some Kafka stream or Kinesis stream, you don't really know what's in it. Just create a copy from job, puts it in S3. Now you can run queries against it like any normal table. You can discover the schema for it. You can really understand, you can run data quality checks against it. You can do a lot of things that way. It also gives you a way to offload the retention from your source system into the data lake automatically. So if you have a MySQL database, for example, that has a lot of traffic, a lot of events coming through, you don't want to maintain lots and lots of historical data over there just in case your pipeline is bad, you need to replay the pipeline or something like that. We automatically stage it into S3. So if you need to replay and you say, oh, wait, I made a mistake, or hey, I need to enhance my data and I want to replay the last year worth of data, like you don't need to keep it in Kafka or Kinesis or in MySQL or in Postgres. It's all in S3. Much cheaper, much easier to use, accessible, and very easy to replay that data. Now, we did a copy from, so in this example, we read from Kinesis data streams, we write into a data lake. It's very raw. There's no modeling, there's no anything like that. It's raw. We automatically discover the schema, do schema evolution if necessary, but then we present that staging table as a table. So if a user comes into Absolver, and I'll show you that in a second, and they want to interact with it, they're interacting with a table, just like they would in a normal database. They don't need to know it comes from Kinesis. They don't need to know it's an S3 object. They don't need to know it's a database table. It's always a table, right? So the transformations, the interface, the experience is that of a table, is that of a database. So the learning curve is actually really low, and it's easy for new users to come in on board. Now, how do you use it? Now that you have the staging table, a user can come in and say, cool, hey, we staged the data, it's there. Now I want to build these data apps or data products, right? Different views of the data. Now, a product manager may do something, a marketer may do something different, but they're all working off of the same data. So I'm not necessarily duplicating the raw data. I may be duplicating some of the transformed data, but that's okay because I'm presenting it in a different way for the different consumers because they have different business needs, right? So if we think about producer-consumer, on the left side, this can be a microservices team, like an API team, a service team that has some data to produce. They connect into their Kinesis stream, for example, into the S3 or their MySQL database. They create a copy from job or multiple copy from jobs that read from the source, stage it in a data lake, And at that point, they're done, right? They can say, okay, data is staged, raw data is there. Mr. Consumer, do whatever you want. So consumer comes in Absolver, they can discover the data. They can see, oh, a producer created a table for me. Let me go use it. Now they are going to start building their jobs on top of that data. Now, the beauty is both producer consumers are in the same platform. So it's not that, producer is saying, I created something, nobody needs to know what it looks like. Consumer created something, nobody knows what it looks like. No, there's transparency, there's visibility, right? So if Manan created one job that reads from a source table and has a certain view of the data, and Roy comes in and creates another job and from the same source and does something else with it, both of us can go into Absolver and see exactly what we did. We can look at the SQL that we did. We can look at the data. We can profile it. We can understand, is it right? Is it wrong? Should I reuse it? Right? So there's a lot of transparency, and that's really, really important. So that's kind of the core concept. Should be fairly simple, but it's an easy way for you in your company to say, hey, producers, this is where you work. Consumers, this is where you work. You can have a producer do everything if you wanted to, but it's an easy way to kind of distribute or separate the responsibilities. So let's kind of walk through this, and I'll have a demo that kind of shows this, but I want to talk through it as well. So the first thing a data producer would want to do is they want to create a connection to their source. And in Absolver, what a connection is really a container for permissions, right? So in this case, we just define a connection with my KDS as the name, and we say this is in region US East 1, and we give a specific role that has the permissions to access that stream and read from it, et cetera, et cetera. So now that we create a connection, the next two things that the producer has to do is they have to create a table. So this is a table that they're going to write the data into. You can see in this case that I'm not defining a schema. I can if I wanted to, but in this case, I don't really know what's in it, and I don't really care because like the stream may add events, or maybe the fields in the events will change over time. I don't want to manage it because it's my staging table. I just want it to be dynamic. I want whatever my developers decide to add, it'll show up in my staging table. I do partition it. So you can see in this case, I have a $sign in front of the event date. This is actually a system table, a system column. So for example, you have events coming in, or you have a file that doesn't have any good way to partition the data, we automatically insert a set of timestamps that will allow us to partition on if you don't have it. Because we ran into situations with customers when they said, well, I need to partition my data, but I don't have a timestamp in my data. I got to go and regenerate all my data with the timestamp. It's not acceptable. So when we ingest the data, we just add a timestamp that's basically like an event date. When that event enters Absolver, we put the timestamp in there, and now we can start partitioning based on that. So now that we have a table to hold the data, the second step is we have to create a job. And it's a very, very simple job. You can see there's not a lot of parameters to it. We basically create a job, we give it a name. We say we copy from my KDS, which is the connection, and then we tell it what stream we want to read from, in this case, storefront events. And then we tell it insert into the table that we just created. That's it, right? If we look for the event date column in the data, we partition the data, we update the metadata catalog, in this case, the glue data catalog. So as data comes in, we just do it. If those are little events, like it is in Kinesis, we basically compact them, right? We merge the small files into big files. We save you space, we give you better performance. And now the table is ready, right? The table is loaded, it's ready to go. Users can start querying it in Redshift, in Athena, actually directly in Absolver, and start interacting with it. Cool. So now that we have the producer part, now let's go to the consumer. So now the consumer comes into Absolver and they say, hey, show me what's there. And I'll show you in a demo kind of like what it looks like. But like, okay, I found a table that I want. What I want to do is I want to take that table and I want to do some aggregation, right? I want to do this case, I just want to create an aggregation of event type, counting of event types, right? So I create my output table. Again, create table, give it a name. In this case, I'm defining a couple things. I'm defining an event ID and a type. I'm going to use the type as my partitioning column as well as the date, but I'm also going to define a primary key. And what that means is that when I have a primary key, every time we process data for an event with the same ID, when we write it into the output, we'll do an upsert, right? We'll do an update into it. So if it's a new event that we've never seen, we insert it into the table. If it's an event that we already seen, but we're sending it again, and we're doing this aggregation to it, we'll update the row in the target table, right? So you don't end up with duplicates. But Absolver does it automatically. You don't see anything here that says, merge when this equals that. Like, we know there's a primary key. We know that you need to update based on primary key, and we just do it. And then the job that you see in step 6 actually does the transformation itself. So we create a job, we tell it insert into that target table that we just defined, and then we give it a select query. And that select query can be anything that you really want, wide range of options. You can use custom functions that we have in a product and really do whatever you want in here. And then once you're done, you run this, and then this starts running and then loads data into the target table. Now, every command that you've seen here, you execute it once and it's done. Like, you don't have to do it again. Table, you create it once, it's done. Connection, you create it once, it's done. If you created a connection to Kinesis and Roy's using it, and then Manan wants to join me and use it too, they can just go connect to the same connection and start using it, right? So this is powerful. You can see here that we're reading from other sources, we're doing transformation, we're pushing it to a destination, and it's running in kind of near real time, but there's no DAG definition. There's nothing that we say, this is how the data need to be stitched together. The product does it all for you automatically. And this is really, really powerful. So now that we have it, we go into Redshift. In this case, we put the data into the data lake. So we create an external schema inside of Redshift, and then we just run a query, and that's it. We create the data. We can also load it into Redshift if we wanted to, and just query it there directly. So that's kind of a flow of how the system works and how kind of simple it is to get started. I want to give you a case study. This is not a customer case study. This is actually our case study. So being a product-led growth company, right, we are focused on monitoring and kind of understanding our user behavior on a platform and extracting insight out of that to figure out what is the best way for us to enhance the product to make it easier to use, reduce churn, and things like that. So the use case, again, is track and measure and understand the user behavior, because we want to improve the retention, adoption, and the activation of our new users. The challenges that we have on our team at Absolver is that we're cost sensitive. We're a startup company. We don't want to go spend tens of hundreds of thousands of dollars on some fancy tool. We have SQL Lake. We have our own tool. Let's go use it, right? We're a small team. In this case, we're just a product team. So we're the ones that need this visibility. We don't want to deal with fixing issues and stuff like that. We want to be nimble. If our team comes around, our CEO comes around, our board comes around and say, hey, we need you guys to look at this metric, or we think that, hey, the user gets stuck in this place, let's go add some more metrics and go build another dashboard. We want to be quick. And then, today we have a bunch of customers in our preview, but as we go GA and we start ramping up, our scale is just going to keep going up and up and up. We don't want to have to reinvent the wheel, rebuild our infrastructure, replace the tooling. We just want it to scale with us. So on the right side, you see exactly what we have. So we have a Kinesis data streams stream where the product writes event into. So when Roy clicks a button, when Roy opens a template, when Roy runs a command, right? Those events get written into Kinesis data streams. And then we bring it into SQL Lake. We stage all the stuff in a data lake. So, our team can just kind of explore. We can do data quality checks against the data, do validation. And then we create the silver and gold tables. One of the silver is basically the modeled table. So we take the raw events, we create a model out of it that renames the columns, adds some computed fields to it, cleans some of the things up a bit. And then from that table, we start building a bunch of views. And this is a activated user view, a pipeline view, like where in onboarding do users get stuck. Is a bunch of things that we're creating on top of that silver table. And then we write that data into our data lake, and then we consume it from Redshift and QuickSight. We also have some Athena use cases, but again, it's in a data lake, so we can pick and choose how we want to use it, but we're using QuickSight for the actual visualization of all this stuff. So that's an example. We have this today. We're going to be writing some blog posts on this as well, so you'll see more of the details of how this works. So in summary, really it's about lower barrier to entry. We really want to reduce the amount of time and effort that it takes our users to do something with data. I mean, when we brought this up, this use case I just showed you, our business analyst, she's very, very smart, but she's not a data engineer, right? So we simply said to our engineering team, give us a Kinesis stream, we'll do the rest. So she did this in a matter of a couple hours. She was able to get the data ingested and modeled and ready to go in less than an hour, I think 30 minutes or so it took her. And then what the time that took is just, building the views that we wanted and tweaking it. But in a few hours, we had a dashboard that we were able to show our board and our CEO and say like, look, this is metrics coming from the product directly. So that was really, really powerful. Reduces the operational complexity. It's one product, makes it easy. There's no DAGs to deal with. There's no complex like orchestration or optimizations behind this, that you have to manage. Everything is done for you automatically. Everything is in SQL. So if you wanted to do CI/CD or you want to automate stuff, you can easily do it. We have a CLI that you can do it with that as well. You can go really quickly so you can kind of take actions in real time. So whether you're starting with batch today and you want to transition to streaming and to more near real time, Absolver makes it really, really easy for you because we treat everything as a stream. So yes, your source may be batch, maybe gets updated once a day, but as that frequency starts to go down, or if you switch from S3 to Kinesis, Absolver can just kind of go with it and you don't have to change any of your code. The code is exactly the same. It's just different connections that we're using. Again, we write data into the data lake or into Redshift or into whatever in as open formats as we can. Data is managed in open formats as much as possible, right? So in the data lake, it's all Parquet and JSONs and Avro, whatever you choose. So it's easy to kind of port that to something else. And then being that engine, we're able to scale to millions of events a second. We have multiple customers who are doing 5, 6, 7 million events a second, which is very, very difficult to do, especially when you're doing stateful transformations like join and aggregations on large windows of time at a very high rate. So this is something that we believe that we're doing different than other solutions. And this platform allows you to bring all the data into Redshift very quickly and easily. So I'll stop here for a second. I'll switch over to my other screen and we'll do a demo. And then that leaves us a few minutes to do Q&A as well. So before we get started, when you log into Absolver, you kind of presented with this screen. So we presented with this screen right here that you have a set of templates that make it easy for you to start doing stuff with Absolver. So if you don't know what to do, how to get started, you can do it right here. You can click on preview template and all the code is here for you with examples. We have some sample data too. So if you wanted to use sample data to just kind of play around and figure things out, you could do it. And then you can bring your own data as well. So these templates are really, really helpful. Get you started. We're adding a bunch more. We're asking the community to also help us and build some if you see something interesting. So I'm going to take this particular template here and I'm going to kind of use this as an example. So going back to what I said before about the producer consumers, I broke up my template in the same way. So you can see here in these first 3 steps, we're acting as a data producer. We create a connection. It's called Absolver S3 samples. You can see the connection right here. So I can click on it. I can see what buckets exist and those kind of things. I can see that I have an orders bucket and there's a job attached to it. There's a job that's doing something with that bucket. So let's kind of look at that. The next thing is we create a table. So in my case, I don't know what's in that bucket. I don't know what the events look like. So I just create a table and I say, I don't know what the schema is, detect it for me. And then we created this job, right? So this is the load orders raw data from S3. It does auto detection of the file type. It says it's from this bucket, from this prefix, and then it loads the data into this target table. And right now it's loading it into the data lake, right? So if I go here, hopefully the demo gods are with me. We should be able to see that, hey, we have a bunch of raw events. You can see it's still very nested, not that easy to use. There's a bunch of other fields, so we add some system columns in here. So this is something cool that we've asked customers asked us to do, is actually list the files and the file size where these rows are. So you can actually run a query against this and say, how many files do I have in my data lake? How big are these files, right? So you can get an idea of the size of your tables. Okay, cool. So now we stage the data. The data is available. We can go into our Glue data catalog. We can see we got this raw data. We click on it. Now we can see, hey, there's a bunch of events coming in. It's kind of like bumpy. This is obviously because it's a sample data, but in reality, this should be like a flat line that constantly bring in events. You know, you may have times where you have dips or spikes or things like that, but this is an indication to you, is a table constantly being updated? Do I have an outage in my data? If all of a sudden I'm seeing a dip in a drop in events, that's an indication to me that, hey, something happened here, right? I need to go look at what's going on. We also give you some field statistics so you can see the column names, what types they are, what kind of density. This is all sample data, so it's going to be good density. It's going to be 100% filled. Kind of top values, some other values in here, distribution, and stuff like that. So it kind of gives you a profile of the data at a high level, and we'll be adding more things in here to make it more robust. But at least it gives you an idea of what's going on. But I can also run a query against it and be happy with it. I can also click in here and I can see the columns. So if in particular I'm interested in column email, I can see what is the rate of events coming in with that email column. I can see how many values I have, distinct values. I can go in here and get some value distribution, right? Like, do I have one value, a few values that are heavy, you know, I see a lot of as compared to others. So again, that kind of gives you an idea of a profile of that particular table and the columns in it. We can also see that there's multiple jobs that are working off of that table. So if I'm a user and I'm coming in, I'm saying, whoa, hold on a second. There's a job in here that says, you know, load raw data. Let me click on this one and I can go in here and I can expand. I can see exactly what that SQL query is, right? So there's no hiding. There's no saying like, Roy created this thing. He will not share with me the SQL, but I really want to know what's there. Now you can put security around this and controls, but for the most part, it's a way to be transparent with the organization so everybody knows what's going on. You don't reinvent the wheel every chance you get. All right, so in this case, we have these tables. So we create a staging table. That's the step of the producer. Now the producer goes away. They're done. They did their part. We don't need them anymore. They're no longer a bottleneck for us. We are now the consumers. So we have an option here. We want to come in here and we want to create a table, an output table. Right? And then we want to do some crazy transformation. In this case, I'm going to model the data a little bit based on my needs. And then I'm going to do some transformations based on my requirements. And I'm going to write the output into that table. So you can see here, I'm doing a create job. I'm saying insert into my table that I defined up here. And then I'm just running a select query, right? I'm hashing the email. I'm adding a computed field in here that basically concatenates the first name and last name. Can be more complex than that, just very simple. And then once I run this job, it just runs, right? And it's right here. So it just runs. I don't have to schedule it. I don't have to orchestrate it. It just runs. If you wanted to, you can go in here and you can look at it. You can see what the job did. I'll show you in a minute what the job monitoring looks like. Now that it's running, you can kind of actually go query the data. So now it's going to come back and you can see it's a much cleaner view of my data because I structured it and I did those things. Now I can also go in here and I can say preview job. And this basically, oh, I think I may have screwed something up. Let me see here. Hopefully it worked. Okay, yeah, cool. So what you can do is because we know that this block of text is the query, you can click in here on the side and you can say, you know, run the statement, preview it, and get help, etc. So you can see here that I actually previewed the data. I took, you know, a little bit of time, right? Just a couple seconds of data, processed about 360 rows of data, and then I produced a sample, right? Now I kind of know, hey, my transformation makes sense. Does it look right? Does it not look right? So before I run the job, I create the job, I can preview it. So this is a really powerful way of kind of interacting with the data. Now, at this point, I'm done. It's very similar to what I showed you in the slides. The producer can now, the consumer cannot create as many jobs as they want, do whatever they want. Now, let's take it a step further. Now, let's say the producer is a certain producer that wants to say, I got a data set and I want to actually share it with more teams, not just one consumer in the same account in AWS. So what I can do is the producer can create two connections, right? An S3 connection and a Glue catalog connection to a target, to another AWS account, cross account access. Then they create a table inside of that consumer catalog, right? Then what they do is they can take the job that they already created, right? This one that's writing into the local data lake. And I can basically say, take the same output and just write it into that consumer account, right? So this is if Roy has his own AWS account, right? And he doesn't want to come work in the data lake account. He wants the data in Roy's account. This job will take the same output that we already produced for everybody else and write it into Roy's account. Now, once it's in Roy's account, Roy can go open up his Redshift cluster and serverless Redshift. In this case, we're just creating an external connection, and then we just run a query against it, and then we got the data, right? So the job that you see on Absolver, this job is constantly running. You can see it right here, right? It's running all the time, producing data. Roy is over here. He can run queries all he wants. The data just continuously gets updated automatically. Roy doesn't need to know anything. If he wants to know, hey, how is my job created? He can come in here and he can actually see the SQL and he can understand exactly what's going on. So that's a really powerful way to do it. You can see that here I have two catalogs, the consumer catalog. You can see I have a bunch of other databases in here, but this is my output table. So as a user, I can go look at it and I can say, oh, in this other account, this other catalog, I have this other table. And then if you go back here, you can go to job monitoring and you can see there's a producer consumer job. And then this producer consumer job is going to give me a bunch of metrics. It's going to show me it's running, how many events were processed, the processing rate, which is a powerful way of telling you, hey, is your data good or is not good? Like, is the flow of data good or not? Right. So if you have drops or something like that, you can see that there's a processing backlog because this is old data. And I told the job to start from the beginning, the first event ever. It's going back and it's saying I have 2 weeks of data to go process. It's not going to take me 2 weeks to do, but it's saying I have 2 weeks worth of data to go process, right? So it kind of helps you understand your SLA a little bit better. And then you can see here processing, you can see cluster utilization. We can see that we don't have any errors at all to deal with. So that makes it easy. The other thing is you can see here, and I'm not going to spend time on this, is you can actually run debug queries inside of Absolver that queries a system table that tells you the state of your jobs, what's going on, what's not going on, how it's working, how it's not working. So that's a really powerful way to do to kind of do your troubleshooting. All right, I'm going to stop here. We're going to have Q&A. So if I didn't leave a lot of time, Manan, if you want to jump back in, we can do that. And then I'm going to leave this here as well.
All right, thank you. We're going to jump into the questions. Manan, the first question is for you. Can you put limit on the resources for different business orgs on serverless?
Yes, so serverless definitely has guide rails built in. So you can go in and decide, like, your starting compute resources, your maximum compute resources, and what actions need to happen based on, what max, if you hit the maximum limits, what needs to happen. So serverless definitely provides guardrails for you to put limits on your data warehouse environment.
Thank you. Roy, a question for you. How do you deal with complex transformations with multiple lookups from different tables from the source?
Can you repeat the question? I'm trying to find it.
How do we deal with complex transformations with multiple lookups from different tables from the source?
So how does Absolver deal with it? So we basically, so when you type your query, let's say the query has, it joins data from multiple places. Behind the scenes, when we parse that SQL, right, when we parse that query, we understand the relationships between the different tables and what's required to bring in. So we're able to stitch those jobs together. We kind of build a DAG on our own. So we have our own way of kind of compiling the SQL query, understanding the relationships, and then building that relationship behind the scenes to know that if events are coming from multiple sources, they need to be joined together. We're able to stream those events together and do the joining and the aggregation behind the scenes. I don't know if that helps. So I didn't go into a lot of the technical details, but.
Thank you. Manan, are there any features in Redshift serverless that don't exist in Redshift managed clusters?
The way you should think about serverless versus provision is like there are basically two deployment options, and depending upon how comfortable you are managing data warehouses, how much control you want over data warehouses, you can choose one versus the other. So provisioned is a really great option. If you want granular control over data warehouses, you want to manage them on their own, you want to manage it yourself. But on the other hand, if you want ease of use, you just want to focus on building applications and let AWS do the management part of it, you can definitely try serverless. And for most part, both of those should give you the capabilities and the flexibility that you're looking for.
Thank you. Roy, a question for you. Can the tool distinguish between a new or an updated record and be used to track changes to a data set?
So by a primary key, so if you define a primary key, then we can say, like, have we seen the primary key before? Meaning it's an updated row. So if it is, then we'll update the target. If it's a new primary key, one that we've not seen before, then yeah, we'll do an insert directly to that, so we can track the changes that are happening to the data set, to the source, and also apply those changes to the target.
Got it. Thank you. Well, this brings us to the top of the hour. Thank you so much for joining us today, and we hope to see you soon again.